Good day. Today we're going to be looking at transformations, specifically the reflection transformation. First, we need to note that a transformation is an operation that maps the original figure, the pre-image, onto a new figure, which is the image. The transformation can change one of three things: the size, the position, or the orientation of a figure. Orientation simply means the tilt, how it's rotated. For a reflection, we are flipping an image over a line, which is simply called the line of reflection. The key parts of this is that each point between the image and the line, and between the line and the pre-image, are the same distance apart. The possible lines of reflection are the x and y axes, vertical or horizontal lines. So this will be x is equal to a number for vertical, y equals a number for horizontal. Or you can have diagonal lines, y is equal to x, y is equal to negative x. That is where it will stop for math 2. All right, triangle 1. ABC has vertices negative 4, 2, so I'm going to apply that, go to the left 4, 1, 2, 3, 4, up 2. This is A. B is 4, 7, to the right 4, 1, 2, 3, 4, up 7, 1, 2, 3, 4, 5, 6, 7. Here is B. And lastly, we have a C of 5, 1. I'm going to follow the order it is written in to draw this figure. A to B, B to C, and then finally C back to A. There's my triangle ABC. Now let's look at the transformation. It is reflected in the x-axis. So here is my line of reflection, and each point is going to flip over it, the same amount of units as the distance from the line. So for A, I'm going to drop 2 to get to my line. I need to drop 2 more. 1, 2. Here is image A. For B, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Image B. And lastly, C, I'm dropping 1. Again, I'm following the order A to B, B to C, and lastly C back to A. There's my diagram finished. You can plot the coordinates down now. We have negative 4, if I can write, negative 4 and negative 2 for A. We have positive 4, negative 7 for B. We have positive 5 and negative 1 for C. Something I'd like you to notice: if reflecting over the x-axis, the only thing that changes is the signs of the y-coordinate. All right. Pause the video and try number 4. Okay, and I'll show you the answers at the end of this. I'm going to do number 3 and let you try number 2. Trapezoid FGHI with vertices F, negative 5, negative 2. G is negative 2, negative 2. H is 0, negative 6. And I is negative 8, negative 6. I must follow my letters. F to G, G to H, H to I, and then I back to F. I'm telling you one more time, you have to follow the orders that the letters are written in. You will have a quiz question, or possibly test question, where your figure might look like this, depending on the order that the letters are written. Please make sure you're following the order. I'm reflecting this in the y-axis. Now, as I'm drawing this, I want you to think, if I reflect over the x-axis, flip the sign of the y-coordinate, what will a reflection over the y-axis do? If you said it would reflect or change the sign to the x-coordinate, you would be correct. So I'm going to start at my coordinates. This will be positive 5, negative 2. This will be positive 2, negative 2. This will be 0, because 0 is 0 from the y-axis, negative 6, and 8, positive 6. Now I'm going to show you if we were to count out to my line of reflection. From F, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Image F, G is 2 away, I'm going to go 2 over. Here is image G. Here will be image I, and here will be image H. Once again, I'm following the same order. F, G, H, I, and close it off to F. There is my trapezoid. It is finished, and it is correct. Pause the video and try number 2. Now I'm going to do 3 more problems and let you try the rest, and I'll show you the answers at the end. But I want to look at numbers 6, number 7, and number 12. I'll do 4 problems. We'll do number 10 too. 6, 7, 10, 12, and then we'll be done with the video. We have a square RSTU with the vertices 0, 3, with 5, 4, 6, negative 1, and 1, negative 2. Here is my pre-image, RSTU. And it says I want to reflect this over the line x equals negative 1. Well, x equals negative 1 is here. So here's the dashed line I'm going to be reflecting over, my line of reflection. R is going to be 1 unit away, so here's my image R. S will be 1, 2, 3, 4, 5, 6 away. U was 2 away. And T is 7 away. There is my image. Go ahead and write out the coordinates. We're done with that problem. Parallelogram CDEF has coordinates negative 4, positive 4, negative 2, 0, 6, 1, and 4, negative 3. I'm following the order these are written in. That C is supposed to be negative 4. I apologize. Now I'm going to draw in the coordinate in the order it's written. C to D, D to E, E to F, and then F back to C. I'm reflecting over y is equal to 2. From E, I'm going 1 up. Here is my image E. F is going 5 up. D is going up 2. And C is going up 6. C, D, E, F, back to C. And we are finished with this one. Rectangle has these vertices. We are reflecting it over the line y equals x. Now, the line of reflection is this. These are the easiest problems to reflect because I don't have to draw the pre-image unless it tells me to. If y is equal to x, then x is equal to y. I'm just flipping my coordinates. So for G, it was 2, -1. I'm moving the order. It is now -1, 2. So -1, 2, -1, 7, -4, 7, -4, 2. You can draw that figure. There's your coordinates. Finished. Let's look at a negative x. If y is equal to negative x, it is no harder. There's 2 steps. I am going to flip them. So -6, -1. But then I'm going to change the sign. Positive, positive. So flip order. Change both signs. For t, it was 0, -3. I'm going to flip the order here. It is going to be -3, 0. Then I'm going to change the signs. Positive, negative, but since it's -0, it doesn't really matter. This is still just 3, 0. And for u, it's -3, -4, so it's going to be +4, and then -3. Okay. We are done for the day. Pause the video, tries numbers 5 and 8. Try 9 and 11. Now let's look at your answers. This is all that I have for you for today. I hope you have a great rest of your day.